I'm going to talk about also measuring functional diversity, but in another ecosystem component in drylands that is also very important but has received much less attention, at least traditionally, I mean maybe 2 decades ago, that is biological soil crust. By biological soil crust, I mean like a complex component tightly related with soil that are composed by cyanobacteria, lichens, mosses, and liverworts. Paula has talked about epiphytic lichens that are tightly related with atmosphere, and this biological soil crust component is mostly related with soil. And of course, desertification has many features, and soil is one of the most important also. So this ecosystem component, as you may say here, is contributing to diversity of drylands because you have plants, but of course you have these lichens. Here hidden are some mosses. And they are organisms that fix carbon and nitrogen, and they also participate in other nutrient cycles like phosphorus and micronutrients. And not only that, but they also change the surface of the soil, modifying soil roughness, acting as sediment traps or seed traps, which contributes to soil dynamics. No. Okay. They also can participate in hydrological cycles because, like you see here, a bunch of mosses that they can absorb water and release in time. That is very important in these drylands where rain events are critical for the ecosystem dynamics. They also may change the reflectance of soil, altering the heat balance of the ecosystem. Here you can see cyanobacteria on soil, this dark surface. Here you see another lichen with a clearly surface. And they also contribute to seedling and germination of some of the vascular plants that are in these ecosystems. So yes, we want to know how this community responds to soil, hydrology, and climate, and this is scenario of desertification. So as Alice and Paula has been talking about, we want to focus on some traits that may be both responsive traits and effect traits. These are photobionts, as Paula has talked about, taxonomic group, I mean cyanobacteria, lichen, and bryophytes, because they per se have some different functions. Growth form, also continuity, because here lichens, for example, on soil are critical in terms of infiltration of the rain or runoff. Also the chemistry, because these lichens can release some chemical compounds that contributes to microbial activity or availability of some nutrients. Also attachment structures, because they don't have roots, but they have like micrometric structures to attach to the soil, and they alter microporosity. And they, as I mentioned before, they present a wide range of colors that may be changing the reflectance of the soil. So as Alice talked, our idea is to have several sites with changing conditions of climate, hydrological properties, soil properties, and functional units. And for this, I mean maybe lichens, maybe a species of lichens that has a similar trait category. And we want to have also the trait value of these functional units. With this information, we are going to calculate these functional diversity indices that Alice explained before. And for us to work on soil, we work also with transect. a line intercept method, and also a sampling quadrat transect. This line intercept method is to calculate, to estimate the contribution of these organisms in terms of the ecosystem compared to other components like vascular plants. And these sampling quadrats are placed here in the interspaces to understand the proportions of each functional groups within biological soil crusts. So in the case of the line intercept, we have this matrix here, and the objective is to say, okay, we have from here to 55 centimeters, we have herbs, then we have mosses, as you may see here, but not so clearly, but here there are mosses, then maybe we can hear bare soil, and just like this to understand which is the contribution of each group or component. With the sampling quadrats, we want to know the abundance of functional units to construct the matrix I showed before. And the aim is to calculate in a known surface dimension, which is the proportion of mosses, for example, which is the proportion of cyanobacteria, and can construct the second matrix, the first matrix that I showed you before. So here, maybe you can see the silhouette of a lichen. And here, under this lichen, we are going to have some soil properties that are changing because of the presence of this lichen. As I told you before, there are some traits that may modify the nitrogen and carbon proportions, the pH, the nutrients that are here, the texture maybe. And all of this can be included in these functional diversity measures. For example, what we have been doing is to collect soil in the first centimeter depth under each functional unit. In this case, I show you here, for example, cyanobacteria, mosses, and lichens. And also we collect bare soil just to compare the values of soil properties here. So thank you very much. This component maybe is kind of, less studied. A lot of advances are getting achieved in the last decade. But some drylands have trees, of course, but most of them have shrubs, grasses, or even nothing of that. But here, these friends are like a very important component. So if any of you have noticed them in any of your places, please come to me, tell me. Thank you.